Hello and welcome to my YouTube channel. In this video, we are going to talk about the microcontroller board which we'll be using to program for this particular playlist. So in this playlist, we are going to work with the STM32 Nucleo F446RE microcontroller board. So to work with this particular board, we have to have some basic knowledge about this particular board. And in this video, I will try to cover all those basic properties. So first of all, Nucleo board are developed by STM32 series, and this particular microcontroller can be this particular microcontroller board can be of 32 pin, 64 pin, or 144 pin, and therefore they are known as Nucleo 32, Nucleo 64, and Nucleo 144. Secondly, we have to keep an eye on the memory available for our use. So these particular microcontroller boards are divided into 16 kilobyte, 32 kilobyte, 64 kilobyte, and up to 2 MB flash memory size. Flash memory represents the memory which will be used by our program, not by the variables. Variables are generally used in the RAM section. So flash memory is the memory which is used by our code. So when we will write any program and upload the program, that program will be loaded into the flash memory. So the microcontroller board are available with 32 pin, 64 pin, and 144 pin, and we can purchase the boards with a flash memory size ranging from 16 kilobyte to 2 megabyte. So here you can see F446RE. This is the board which we will be using in this particular playlist. If you are interested in purchasing any other board, you can purchase any other board falling in this particular range. So F446RE comes with 512 kilobyte of flash memory. Now let us see a bit more detailed way how these particular boards are divided. So these boards are divided into further 4 sections like mainstream boards, ultra low power boards, high performance board, and wireless board. So depending on your use, you can either go for one of these boards. And these boards here in this slide, you can see we have different colors allotted for different types of boards. The blue one are the main board, which are generic boards with all the features, normal features. Yellow are those boards which are generally used for ultra low power applications. This board with cyan color are used for high performances, and the gray colored boards have wireless features. That means you can use Wi-Fi or similar features. So what are the prerequisites for this particular course or particular playlist? First of all, you will have to have a PC with Windows installed, Nucleo F446RE microcontroller board. Otherwise, you can go for any other board which falls in that particular category. You will have to have a small mini USB cable to connect with the microcontroller with the PC, few male and female header wires, some push to on switches, and some LEDs. Let us talk about the different parts of the particular microcontroller board. First of all, here this USB connector is used to provide the power to the microcontroller board. Then this particular board can be divided into two halves. You can see the upper half, this particular section, and the lower half, this particular section. This particular section at the upper half is the debugger section, and the lower section contains the main microcontroller, which is located here. There are two user buttons available. One user button is for resetting the microcontroller, and the second can be used for normal usages. Of course, you can use this particular button also, reset button also, for other applications. You will get one microcontroller, STM32 microcontroller with 64 pins in the center. And we also get connectors which can be used with the Arduino Uno boards. Then there is an LED here which is connected with the port A5 of the microcontroller. Like I said, the upper and lower half can be used separately. So upper half can be used as a debugger for any other microcontroller which falls in the STM32 family. Then you have connectors which are also known as morpho extension header, which can be used to connect with external peripherals like LEDs, switches, beeps, or any other motor or transistors. So we have these pins which are coming from the microcontroller. And then, like I said, we have the facility to connect Arduino extension boards here in the cyan region. So these are the connectors available. Remember, there are two jumpers here. By disconnecting these jumpers, we can disconnect the debugger from this particular microcontroller in the center, and we can use only this debugger section to program any other microcontroller which falls in the STM32 family. For programming the external microcontrollers, we can use these lines. The details of these programming techniques are available in the reference manual. So apart from that, we have the VDD for providing the power supply and other pins available for the usage. Remember, this particular section of connectors are known as CN7, connector 7, and this section is known as connector 10, CN10. In the middle, we can see there is the Arduino board's connector lines, which are known as CN5, and here in the right you get the CN6 section, which have the same features which are available with the Arduino board or Arduino Uno board, precisely speaking. Similarly, in the lower section we have connector 9 and connector 8, which are again connected to the features which are available with the Arduino Uno boards. So if you are interested in the same pins which are available with the Arduino Uno, you can use CN5, 6, 8 and 9. And like I said, we have connector 7 and connector 10, which will provide you the pins coming from the main microcontroller, which is the STM32F446RE. So here we have 64 pins. For further details, you can visit these two links available. I have created an Excel file to show all the pins available with the STM32F446RE microcontroller. So for the connector 7, odd pins like pin number 1, 3, 5, 7 up to 37, we have these peripherals available with those pins. Connector 7 even pins like 2, 4, 6, 8 up to 38, we have peripherals available within this section. So remember, one pin of the microcontroller can be used for different peripherals or different features. Like here in pin number 1, we can use it as PC10, 10th pin of the port C. We can use it as the UART3's transmission line. We can use it SPI3's SCK line or similarly. So these pins can be used for alternate functions provided we have to change the configurations accordingly. Similarly, for pin number 10 or connector 10, we have odd pins and even pins which are demonstrated here. So these pins further can be used for multiple functionalities, but remember, at a particular time only one of the features will be enabled in the pins. For example, if we take the example of PA5, then this PA5 can either be programmed as ADC pin, PWM pin, DAC pin, SPI pin or USB pin. We cannot use multiple functionalities using this particular single pin. So what are the peripherals available with this particular microcontroller? This microcontroller can work with a crystal frequency up to 180 MHz. This microcontroller can work between the voltages 1.7 to 3.6 volt. So below 1.7 and above 3.6 is not recommended for this particular microcontroller. We have serial communication features. We have 512 kilobyte of flash, that means the program that you can upload, 128 kilobyte of SRAM, 4 kilobyte of SRAM for backup purpose, 10 general purpose timers, 2 advanced control timers, 2 basic timers, 4 SPI, which is 4 wire communication. So 4 wire communication modules are available. So you can go for 4 such different modules, 4 I2C modules, which is also known as 2 wire communication module. Apart from that, we can use 2 CAN bus communication protocols. Similarly, HDMI, camera interface, up to 50 GPIO pins with interrupts we can use. We have 12-bit ADCs. So we have 3 12-bit ADCs available with the microcontroller board, which are supporting 16 channels, and 12-bit DAC, digital to analog converters, mostly used for PWM purposes, and we can have 2 such channels with this particular microcontroller board. So for further details, you can visit this particular link to get all the details about this particular microcontroller board. To program the microcontroller, we'll be using CubeMX, which is freely available, and I have shown you how to download and install the CubeMX software in the previous video. This particular software, CubeMX, can generate code for different IDEs like Kyle, IAR, STM32 System Workbench, and Atomic. Remember, Kyle, IAR are generally paid versions, so they are generally available with code limited versions in the free versions. So with free versions, you cannot go beyond, in general, 32 kilobyte of program. So If you are interested to work with Keel or IAR, remember in the free version, you can go for maximum code size of 32 kilobyte. Otherwise, you can work with STM32 Workbench, which is free and it is able to program up to the whole memory of the microcontroller, which is unlimited size of the code. Please download and install the ST-Link V2 driver, which can be downloaded from the link provided below. In the Google, you can just type ST-Link V2 driver, go to that particular website provided by the STM32, download it and install it, because this particular driver will be helpful to communicate with the microcontroller board. So to upload and download the code, we have to use this particular driver which is provided by the STM32. If you have any doubts or suggestions, please use the comment section to express your comments or doubts. If you have not subscribed my channel, then I would request you to please subscribe the channel. If you have any suggestions or comments about this particular video, please share your comments and suggestions in the comment section. Thank you and have a nice day.